All right, let's talk about a truly wild idea. We're going to explore how hijacking the security model of a cryptocurrency could completely reshape the world of high-performance computing. This is decentralized quantum computing.
You know, all that energy, all that incredible computing power that goes into crypto mining, it gets a lot of criticism, right? People call it wasted computation. But what if we could flip that on its head? What if that exact same process could be used to tackle some of the biggest challenges we face in science and industry? That's the core question we're diving into.
So here's the plan. First, we have to completely redefine what mining even means here. Then we'll get into 4 mind-blowing use cases: building a global quantum computer, creating a stress test for tomorrow's AI, sparking a massive competition to solve real-world problems, and finally, creating a brand new marketplace for science itself.
Okay, first things first. We need to throw out the old idea of mining. This isn't just about securing a ledger anymore. The fundamental shift here is turning that security mechanism into a source of genuinely useful, productive work.
And this right here is the key difference. Traditional proof of work, like with Bitcoin, is basically a race to guess a random number. It's brute force. But this new model, it completely changes the game. Instead of guessing, miners are actually solving structured, complex quantum problems. The work itself has value.
This new mechanism has a name: quantum proof of work, or qPoW. It means the security of the whole network is directly tied to miners doing useful calculations. The work they're proving isn't just a random guess, but a real, verifiable step in a giant, ongoing quantum simulation.
And that's the paradigm shift. You're not just protecting transactions anymore. You're securing the network by participating in a global tournament where the rewards go to whoever can best solve these incredibly complex computational problems.
So, let's jump into the first major use case and see how this all comes together to build something amazing: a global, decentralized quantum computer that pretty much anyone can use.
This quote from the source material just nails it. The entire blockchain, with every single miner working together all across the world, effectively becomes one massive, distributed quantum simulation cluster.
So what are these miners actually doing day to day? They're not just running some simple program. They're doing the real heavy lifting of quantum simulation. We're talking complex linear algebra on their GPUs, finding the lowest energy state of a system. They're each contributing small pieces to these much larger, iterative solutions.
Now, why does this matter so much? Because it completely opens the doors to high-performance computing. Imagine a university research lab. They could never afford time on a national supercomputer. But now they could tap into this global, permissionless network to run huge simulations for things like quantum chemistry or discovering new materials. It's a game changer.
Okay, so that quantum simulation power, it has another incredible application: stress testing artificial intelligence. This network can actually help solve one of the biggest problems we're facing in AI safety right now.
I mean, seriously, think about this question. When you have an AI model with trillions of parameters, how on earth can you be sure it isn't hallucinating or making a critical mistake in its reasoning? Trying to test it is just an impossibly huge task.
Well, this is where qPoW comes in with a really brilliant solution. Since the miners are always running these quantum simulations, they're constantly creating a stream of what's called ground truth data, answers that are guaranteed to be correct. AI labs can then use this data as a super hard benchmark to test their models against, helping them find exactly where and why their AI is failing.
So the bottom line is, this network becomes a global, unbiased, and incredibly difficult test for the next generation of AI. It's a way to actually measure things like hallucination rates and verify an AI's reasoning in a way that just can't be cheated.
All right, let's move on to our third use case. This one takes that idea of useful work and applies it directly to some of the most pressing industrial problems out there. This is where security literally becomes the solution.
Now, what's really cool about this whole thing is that the system doesn't force everyone to use the exact same setup. Instead, it creates this competitive ecosystem where all kinds of different approaches can go head-to-head on the same playing field. This idea is called Bring Your Own Solver, and it's a total game changer. It means a miner can plug in whatever they think is fastest: a super optimized GPU program, a specialized FPGA chip, or, maybe down the line, even actual quantum hardware like an ion trap computer. The best solver gets the block rewards.
And just look at the difference here. Bitcoin mining, it basically turned into a two-horse race between GPUs and specialized ASICs, but a bring-your-own solver model?
Whoa! It's a total free-for-all in the best way possible. You've got all these radically different technologies competing to solve problems faster, and that competition is what drives real scientific progress.
And what kind of problems are we talking about? These are not abstract math exercises. These are the core industrial challenges that companies spend billions on every year. Things like finding the absolute most efficient shipping routes, scheduling a factory floor, designing better computer chips. The underlying math is the same.
And this all brings us to the grand vision. What happens when you put all of these different pieces together? You end up with something totally new, a decentralized marketplace for scientific computing.
So picture this workflow. A chemist, right? She's trying to design a new molecule for a drug. She submits its properties as a problem to the network. Miners all over the world then fold that problem into their mining process, and they compete to find the most stable structure. The winning solution gets verified by the entire network and locked onto the blockchain forever.
And using a blockchain here gives you these powerful guarantees that are frankly often missing in traditional science. The results are verifiable by anyone, they're easily reproducible, and they're resistant to any kind of censorship or control. It tackles major issues, like the replication crisis in science, head-on.
So what this all builds up to is a true permissionless marketplace for computation. Anyone, anywhere in the world, can pay to have their hardest problem solved by a global, decentralized supercomputer that's constantly being upgraded by this fierce, innovative competition.
And that leaves us with a fascinating final thought. We tend to think of science happening in big universities or corporate labs. But what if this model is the seed of something entirely new? A future where the next great scientific breakthrough doesn't come from just one institution, but from a global, decentralized consensus. What would that world look like?